Alrighty, 7.5 day 2. Short lesson here. Got a couple more things on graphing inequalities that we want to touch on. The first two here, nothing new in the process, but I just want you to be ready for kind of some abnormal results that you could see and to be ready for what they mean. First step here with my first inequality is going to be subtract x, because I want to, basically I want to graph the line 3 minus x, which I'll go ahead and do now. Got my y-intercept right here of 3. And then, of course, I'm marking additional points based on the slope, which is -1. And I'll put in some dashed lines here. Remember, they're dashed because I want to make it clear on my graph that these points that I'm plotting right now, they're not solutions. And we'll call that inequality number 1. If they were solutions, then I would mark them with a dashed, or with a solid line rather. All right, it does not go through the point 0, 0, so let's test it. Plug in 0 for y. Right, so I put in 0 for x, and I get 0 is greater than 3. Is essentially what that says. Okay, that is not true. So all my solution points you would find over on the other side. I have another one to do here, so I'm not putting the arrows in yet. This one has the same slope, except it's got a different y-intercept down here at -1. Again, a dashed line. I'll label that's inequality number 2. Um, 0 is less than -1. Okay, that's not true. 0 is actually bigger than -1, so I would have these arrows going the opposite direction, which gets us to this case that I wanted to talk about. These lines are parallel. They're never going to intersect, and the arrows are going in opposite directions. Right? You'd be looking for where the arrows point towards each other as to where to shade for solutions. And you'd see if this comes up, you don't have any. Okay, so that is conceivable to get that, it's not possible to draw your shaded area and represent your solutions if your system of inequalities just doesn't have any solutions. Here's another one that has a result that we haven't seen. Not as weird as the last one, but that looks like the same inequality as the first one we did on the last one. The second one is not. This has got a couple of steps to get this ready. 2y is greater than 3 minus x, and then I got to divide by 2. And there's my second one. So my first I can put up here pretty quick. Not a whole lot to do with this one other than to just basically copy down what I had from the previous problem. And we already tested 0, 0 and saw that it was not a solution point, so we'd have to shade the other side. Well, actually, matter of fact, this one might have the, I should check, this one might have the inequality sign going the other way. It may have fooled me. I thought it was the exact same one, but it might not be. Oh, sure enough, the inequality sign is going the other way, which would tell you one thing, and I'll do the test point just to verify it, but this should mean that when we test the point 0, 0, it should work. See, 0 is less than 3, and now that is true. So that's actually good to see. That inequality flips, that means to shade the opposite side. But you could, and that's why a test point will work, is you'll see testing the point 0, 0 shows you what's going on. When that inequality flipped, it became a solution point. All right, one more to graph here. Oh, we're at 1.5 right here. Now we got to go down 1 over 2. As this one has a slope of negative 1/2. Should have also labeled these that there was constraint. Whoops. Inequality. I shouldn't be using the term constraint yet. I'm thinking ahead to section 6. We'll get there, but not yet. Now we got to figure out what side to shade. We'll test 0, 0. There's nothing special about the point 0, 0, but if I can, I like to. So, if I put in 0 for x right here, that term will disappear, and it'll just say that 0 is greater than 3 over 2, or 1.5. Well, that's not true. 0 is not greater than 1.5, it's less than, so my solutions are on the other side. And I would shade above, and then I would see that right here, that's where you'd find all my solutions. Now notice those lines would keep going, so this region of solutions is what we would call unbounded. Okay, one of the other ones that we saw, it kind of formed like a triangle. I think the two of them, one had a quadratic as well, but the other two solution sets that we saw were like this, like enclosed space. Okay, one was a triangle and the other was almost kind of like a half circle formed by the quadratic and a line. That case can come up, but this can happen too, where a set of solutions doesn't have to be an enclosed space. Okay, it doesn't mean we did anything wrong. Some solution sets just, that's how they come out. It's a little extension of an application problem that we did. We were producing some kind of digital device here, and we had seen, we were trying to kind of find, based on supply and demand, how many we should produce. We had said 3 million, and then we'd got our market value price of $120. Okay? What we're looking at now are these area of solution points formed by these inequalities. Okay? This is really more just interpreting a result to kind of give you some context as to, what the area of solutions, those points in this region formed by the inequalities, what they mean. We haven't done anything with that because we've just been practicing throughout this section, on a graph how to find that space. So above here, it calls that your consumer surplus. The area of that enclosed region would tell you how much customers as a whole, okay, so think of the whole market for the product, how much total they would have been willing to pay above what they actually paid. Okay, this would be based off of these numbers. If we went off the supply and demand intersection point of producing 3 million at an asking price of $120. Okay, so basically it becomes like a triangle because I just want the consumer part of it. So I have 1/2, and then this line here is right at 120, and this goes up to 150. So that side of the triangle is 30, and then the base of it is like 3 million. Crunch those numbers, and you see for the consumer surplus as a whole, they would have been willing to have paid $45 million over what the market actually paid for the product. Down at the bottom, we have what's called a producer surplus, which would tell you how much less money the manufacturer would have been willing to take below what was actually paid. So we'll do the same thing, and we want the area of this. It's still a triangle, so we do 1/2. The base of it is still 3 million. Now the difference here is this goes from 60 all the way up to 120. That side of the triangle is 60 instead. Crunch those numbers. And we can see that the producer would have been willing to take $90 million less than what was actually paid. Okay? That's where we're headed a little bit with all this inequality stuff. What we really wanted to do here in section 5 is to make sure that we're comfortable, practicing on a graph how we find all that, which is important, right? We can't really get into the results of the context of a problem if we can't create the graphs and figure out where our solution sets are. But where we're headed now is, okay, in the context of a problem, we get these shaded regions that have all these solution points, and we want to get into what do they mean, and then what are we going to use them for.